Florida looks like the perfect place to live by the water, but the same water that makes the state so attractive is becoming its biggest problem. In Florida, water is not dangerous, only at the coast. It arrives with hurricanes, rises from underground, and reaches drinking water when salt gets into freshwater supplies. And while people keep moving here for the dream, the Sunshine State is facing an uncomfortable question. How do you live by the water when that water starts coming from everywhere? This is a story about Florida's fight with water, and with its own geography. Most of Florida sits on limestone that is tens of millions of years old. The state was once the floor of a shallow sea. Shells, corals, and the remains of marine organisms built up on the bottom. Over time, they compressed and turned into limestone. Water moves through this rock easily. Even ordinary rain can seep through the soil and slowly eat away at the limestone from the inside. Over millions of years, empty spaces formed beneath the state. And when one of those spaces becomes too large, the ground above it can collapse. That is how sinkholes form. Seffner, 2013. A man was sleeping in his bedroom when the ground opened beneath the house. He was never recovered. Dover, 2010. More than 100 sinkholes opened in just a few days. Fields, roads, homes, and utilities were all at risk. In central Florida, there's an entire belt of counties known as Sinkhole Alley, and right there is the Villages, the largest retirement community in the world. About 150,000 people live in an area where sinkhole risk overlaps with a huge residential community. The problem is not one hole in the ground. It is the fact that empty spaces can hide beneath roads, homes, and entire neighborhoods. Limestone does not work like a concrete wall. It lets water pass through. And that raises the next question. Can you stop the ocean with a wall if the ground beneath that wall also lets water through? When sea level rises, many places build seawalls. In the Netherlands, that can work. The water is outside and the wall can be strengthened, but Florida is more complicated. Here, the ground is porous. When sea level rises, the ocean puts pressure on the underground system. Groundwater rises with it. Then water starts appearing where no one expects it, out of storm drains, through cracks in the pavement, on streets during clear weather. In South Florida, this is called sunny day flooding. Since 2000, this kind of flooding has become 4 times more common in some areas. Miami Beach is responding with pumps, raised roads, and rebuilt drainage systems, but this is not a victory over water. It is an attempt to keep the city dry while the water keeps rising. But if water moves underground, the next question gets closer. What happens to the water coming out of the tap? In Miami-Dade County, get their water from the Biscayne aquifer, an underground layer of limestone that stores fresh water. About 2.5 million people depend on it, but it is not a sealed tank. Salt from the ocean can get into it. As long as there's enough fresh water underground, the salt does not move very far. But when groundwater levels drop and the sea keeps rising, the balance shifts. Saltwater starts taking the place of freshwater. Hollandale Beach, for example, lost 6 of its 8 freshwater wells to saltwater intrusion. And in Boynton Beach, the salinity level in one well reached about half the salinity of ocean water. You cannot drink water like that. So how did there become less freshwater underground, and why did it become easier for salt to move inland? The answer is in the wetlands. Before the 20th century, the Everglades in South Florida were not just a swamp, they were a water balance system. Water moved from Lake Okeechobee toward the ocean across a flat plain. The Everglades filtered water, recharged underground freshwater supplies, and helped hold salt near the coast. But in the early 20th century, engineers did not see the Everglades as protection. They saw useless swampland. They drained it, cut it with canals, and turned it into farms, roads, and neighborhoods. South Florida gained more land for growth. But by losing the wetlands, it also lost part of the system that kept its water balance in place. There was less freshwater. Wells began to turn salty. The swamp was not the problem, it was the solution. And Florida removed it. Today, the state is spending billions of dollars to restore a system nature used to provide on its own, and that work will take decades. Now the water comes from above. Why does the shape of Florida itself make the state one of the main targets for hurricanes? Florida is a long, flat peninsula between the Atlantic Ocean and the Gulf of Mexico. On both sides, there is warm water where tropical storms can gain strength. So Florida does not have just one dangerous side. A storm can come from the east, the west, or the south. The statistics show it clearly. About 40% of all hurricanes that hit the United States hit Florida. And if you look at the map, The main point becomes obvious. Florida has almost no safe side. A storm can hit one coast, cross the low peninsula, and then move back over warm water again. The land does not help much either. There is no mountain range to break the wind. There is no sharp rise in elevation. Wind, rain, and storm surge can move far inland across a low surface. That is the price of Florida's shape on the map. Almost every coast has its own hurricane route, but there is one place where a hurricane can become dangerous even far from the ocean: Lake Okeechobee. Lake Okeechobee looks like an ordinary large lake, but its extreme shallowness, with an average depth of only about 3 meters, makes it extremely dangerous during hurricanes. Strong winds can rapidly push water toward the southern shore, raising the level and putting massive pressure on the dikes. In 1928, a powerful hurricane passed directly over the lake, broke through the old earthen dikes, and flooded the low-lying communities of Belle Glade, Pahokee, and South Bay with water up to 6 meters deep, killing at least 2,500 people. After the disaster, the 143-mile Herbert Hoover Dike was built around the lake, but the problem was never fully solved. Today, the lake must be constantly and carefully managed. Too much water threatens the dike and communities to the south, while too little water sent south harms the Everglades and allows salt water to intrude inland. Okeechobee perfectly illustrates Florida's fundamental reality. Water here cannot simply be stopped. It must be directed, held back, and pumped. Florida is one of the flattest states in the country. Its average elevation is about 30 meters above sea level. For comparison, neighboring Georgia averages about 180 meters and Colorado averages about 2,070 meters. By 2050, sea level along Florida's coast could rise by about another 30 centimeters. For a low-lying state, that means more flooding. Streets go underwater more often during high tides. A house bought today will exist in a different risk map. It may become harder to insure, more expensive to repair, and harder to sell if the neighborhood floods more often. By the end of the century, roughly 1 in 8 homes in Florida could be at risk of flooding. That is hundreds of billions of dollars in housing. And here's the problem. Insurance is based on risk. If hurricanes, flooding, and expensive repairs happen more often, an insurance company raises prices, limits coverage, or leaves the market. In some areas, home insurance can reach $10,000 to $12,000 a year. Major insurers are leaving the market or limiting their exposure. Private companies are increasingly refusing coverage. Insurance in Florida is not a separate issue. It is the sum of all the state's risks converted into money. Florida is not giving up. It is building pumps, raising roads, and restoring the Everglades. New buildings here are among the most hurricane-resistant in the world, and $8 billion have been invested in wetland restoration. But all of this slows the process. It does not stop it. The question is not whether Florida is sinking. The question is how fast.